Hey everyone, my name is Matthew. Excited to be here. I'm one of the co-founders of OpenGradient. And today I'm here to talk about how to make intelligent adaptive agents in real time. A little bit about myself before I get started. I spent most of my professional career as a research engineer at a quant fund called 2 Sigma in New York. When I was in school, I'd also done stints of HCI as well as ML research, notably in applying unsupervised learning methods in market regime detection and using that for portfolio optimization. And I will give everyone a quick rundown of OpenGradient shortly, but excited to first talk about what the road to a trillion advanced agents kind of looks like in my view. So I kind of think about agent development in a couple different stages. Stage one, you have agents that can synthesize and reason about with data, which you can already see with all these Twitter agents popping up, tweeting interestingly provocative things. Secondly, you have stage two, which is agents are able to complete tasks on the behalf of their human overlords, such as placing simple transactions, such as buying a simple token. And you kind of already see a lot of AI agents, notably on the near chain, kind of able to do this and serve as assistants. And here I've also attached a little screenshot of one of the tweets that Ilya had put out about how a lot of these agents are kind of helping humans with mundane tasks like routing trades and routing orders. And lastly, the kind of final stage for AI agent development, in my opinion, is when AI agents are able to surpass, clearly, human abilities in handling complex tasks. And this might look like AI agents that are able to run fully autonomous companies, AI agents that are able to run and participate in DAOs, as well as AI agents that can manage portfolios and be able to trade effectively and generate profit consistently. But if you look at the state of frontier models, LLMs, and AI agents today, a lot of them are extremely intelligent and especially given the previous panel, can access things such as tool calls and RAG in order to make it smarter. But when you ask it, hey, what is the price forecast for SUI? What asset should I buy to minimize my risk-adjusted return, to maximize my risk-adjusted returns, things like that, the LLMs or AI agents aren't able to give you a very textured or detailed response. And in our view, we kind of want to build AI agents that are able to address those tasks and give you textured responses and execute on them effectively. And from my view, there are essentially 3 different kind of bottlenecks and technical hurdles that we need to overcome in order to advance agents from stage 2 to stage 3. Firstly, data pipelines. You need to give AI agents the ability to reason about with more complex and a wider variety of different data sources. As an example, if you have a portfolio manager agent, that agent might want to be able to pull Twitter data in order to analyze the sentiment around certain crypto assets on crypto Twitter. Secondly, computational workflows. Allowing AI agents to venture outside the world of using a large language model and run a computational workflow that might involve, as an example, a mean variance portfolio optimization workflow that gives the AI agent the ability to optimize its portfolio holdings or run a simple risk analysis on various assets, things like that, allowing it to actually perform detailed analysis and become smarter with domain-specific intelligence. And lastly is agent interoperability. So I'm extremely personally bullish on the ability to allow agents to compose with one another in order to complete extremely complex and abstract goals. As an example, a portfolio manager agent might leverage an execution agent in order to find the best venue to trade, to minimize market impact, or to minimize the cost and fees that they would have to pay in order to cross the spread, and might use a marketing agent to pump tokens that it might hold in its portfolio, things of the sort. And I think these are all extremely exciting kind of primitives that we're building at OpenGradient as well, which I'll get to shortly. And this is just a quick screenshot of a little piece of writing that we had put out about how the 3 kind of key pieces that I just spoke about will allow agents to become more intelligent with access to computational workflows, data pipelines, and access to other agents, and allowing us to compose different agents together to create powerful computational applications. But what's next? So briefly on what OpenGradient is, we're building a full stack infrastructure platform that allows developers to very freely be able to build AI or ML applications on chain in a way that is both verifiable and extremely seamless. We want to allow developers to integrate quite simply, any model into any application on any chain. We have an infrastructure layer that has various nodes that handle compute-heavy tasks, including inference, including running secure data pipelines. We have our blockchain network, which allows developers to build using these data pipelines, using different models directly in their Solidity smart contracts. And we also have cross-chain messaging that allows these computational workflows to service apps or agents or protocols on any other chain. We have a model hub that is live at hub.opengradient.ai that you can check out with a couple hundred models. Many of them are Web3 specific. We host sentience, large language models. So this is Dobby. We host Flux, small language models. We have many, DeFi quantitative ML models that do spot forecasting, volatility forecasting, risk analysis, and more. And this is all live. You can go check out and play around with those models, and we have many active builders building with these models. And lastly, we have Pythonic SDK that allows developers to leverage our tech and interact with all of these models and workflows without having to deal with the complexities of blockchains for smart contracts. And we also partner very closely with clients in order to get their agents, protocols, and applications off the ground by partnering with them, and a lot of the time building models and agentic workflows alongside these clients. And I'll get to a couple interesting use cases later. A quick overview on how we make this magic happen. Essentially, it's through node specialization. So unlike a typical blockchain, we have many different types of nodes that do very specific things, including inference nodes that run verifiable inference and generate proofs and attestations, data nodes that are able to run secure data pipelines to make these workflows data rich in nature, and a decentralized file store where all the models are stored. And we have today one of the only repositories of Web3 specific models, including, like I mentioned, kind of these small language models, large language models, and a variety of quantitative DeFi focused ML models that allow developers to build many of these powerful AI agents that can manage portfolios, trade, analyze risk on different assets. And we also host, many of our partners' models, including Pond's model, which does Sybil address detection, and Repos and Filecoin's models, which do minor allocation and reputation analysis. And kind of tying this back into how we intend to make AI agents intelligent and adaptive in real time. By leveraging these computational workflows powered by these highly specific models, we are able to give AI agents domain-specific intelligence. Instead of getting an extremely generic response from Claude, now when you work with clients on OpenGradients like Exponent, when you ask it, hey, give me a short-term price prediction on an asset, or give me the risk profile on Sui, it can actually query these models and give you, historical forecasts as well as the current live forecast that can give you a much more textured and detailed response that actually addresses the user's concerns. In this case, if I want to buy Sui, I want to understand the risk profile, the current volatility associated with the crypto asset. Another interesting one of our clients, which is Double Up, they are a gamified prediction market protocol, launched an AI agent that allows users to actually bet against the AI agent on the price forecast of different crypto assets. So the human user can type in some price forecast, and the AI agent, of course, can't forecast these prices, so it runs a spot forecasting model on OpenGradient, and that's able to give it, a very specific forecast powered by time series analysis. And in 30 minutes, when the market resolves, either the user doubles up, or doubles their money, or they lose their stake, right? And from a quick preliminary analysis since the launch of this agent last month, we can see that, hey, users actually perform worse than the AI agent because the AI agent has obviously access to ML models that can inform it of what the price predictions are. And this is kind of like a very bare bones, live in production, dealing with real user assets example of how we can give AI agents the ability to predict prices, to eventually trade and manage portfolios effectively through the use of these modular AI and ML focused workflows. And we're also working with many clients, big DeFi protocols, on building analytical quantitative DeFi AI agents that can give them, that can give the protocol and users of the protocol access to many of these analytical capabilities and workflows powered by the kind of AI and ML models on our hub and on our infrastructure. So you can ask, these quantitative agents, hey, what asset should I buy to maximize my risk-adjusted returns? If I have $1 million of Bitcoin, which vaults should I deposit in order to improve, to maximize the yield I can get on these assets? And this AI agent is able to query and leverage these workflows in order to help users achieve these abstract goals. So I have a quick demo here, which unfortunately probably is not going to load, but this is just a quick example of, if you go to hub.opengradient.ai, you can go upload any arbitrary AI and ML model and inference it within seconds verifiably. And there are tons of different models on there, courtesy of us, as well as many of our modeling partners, as well as individual contributors for AI and ML specific Web3 models that you can go and play around with today. With these models, we're excited to be introducing them as tool calls to the AI agents, and we're working with many of the popular frameworks as well to implement these tool calls. Very excited to be, unleashing the new era of intelligent agents that can leverage these computational workflows to do much more complex and abstract tasks. Thank you.